All right, let's talk about aromatic compounds for a little bit. And you probably remember the structure of benzene. We've seen this a few times throughout the course. So benzene has a formula which is C6H6. Don't get benzene confused with this compound, which we talked about a lot in Organic Chemistry 1. This is C6H12. This is cyclohexane. So cyclohexane is not an aromatic compound, so I'm just going to erase it because it's not part of this class. So aromatic compounds, or sometimes we refer to them as arenes. So aromatic and arenes include benzene and derivatives of benzene. And so we see here that if you have a methyl group attached to your benzene, we call that toluene, and then this compound here is an interesting name, orthoxylene, and that's a dimethylbenzene. But anyhow, the first benzene derivatives were isolated from fragrant balsams and oils that came from trees and plants. And so since they were fragrant, okay, you can see that's where the word aromatic comes from. However, now many more aromatic compounds have been discovered since then, and many of them are in fact odorless, and some of them don't smell good at all. So the term just stuck around, but really, if you break it down to what we're going to talk about and what we're dealing with when we're dealing with an aromatic compound in this class, it usually means something that's a very stable compound. Okay, and we'll get into the details of why aromatic compounds are so stable later on. And if you're interested in the medical field, if you want to be an MD or a dentist, or maybe be involved in pharmacy or nursing or something like that, you definitely want to know what an aromatic compound is, because aromatic rings are very common in drugs. Okay, and we see here atorvastatin or Lipitor. Okay, this is a cardiovascular drug. It was discovered in the early 80s, I think, and it was patented, maybe in the mid 80s or something like that. It's what we call a statin. It's a medication that's used to prevent cardiovascular disease in people that have a high risk for cardiovascular disease, and to treat abnormal lipid levels as well. Another interesting compound that's down here is Plavix or clopidogrel, and clopidogrel is sold under the name Plavix, and it's an antiplatelet medication. It's used to reduce the risk of heart disease and stroke in people who are high risk. Prevacid is a medication that reduces stomach acid. It's what we call a proton pump inhibitor, and it can be used to treat peptic ulcer disease. But anyhow, you see that all of these compounds have aromatic rings in them. And you can see the molecular structure of coal is shown here. And coal just involves a haphazard arrangement of aromatic rings that you see here highlighted in orange, connected to each other by non-aromatic links that are shown in the green boxes. And when we heat coal in the presence of oxygen, a combustion process takes place, producing carbon dioxide and water and other products as well. So again, we take our coal, we combine it with oxygen, we produce CO2 plus H2O plus other products, plus of course we liberate heat, okay, heat energy. And the reason why we liberate so much energy is because all of the carbon-carbon and carbon-hydrogen bonds are broken and are replaced by lower energy carbon-oxygen double bonds in CO2. And so when we release that energy, we can use it, or that heat or that energy, we can use it to make electricity. And in fact, 1/4 of the electricity that's used in the United States comes from the combustion of coal.